Hello students, welcome to IMS Gate Academy. In the last session, I explained well about the semiconductors, different formulas I gave it, and how that formula comes, that also I explained. So the subject is very important for the EDC students. They can make a good score. I said already 8 to 12 marks if you want to get very easily, EDC is more important now. That's why don't miss this subject. Some students are going to have some doubts. The subject is somewhat difficult. It is not possible to do the problems from the EDC. If the student is very good in concepts and also in the formulae, then they can do any question very easily now. That's why you try to be perfect in markupping the formulas only now. Those formulas will be helpful to do any sort of questions I say now. Understand that now. Yes, in this section, what we are going to discuss. The last session where I stopped, the Fermi level in intrinsic semiconductor I explained. Today, I would like to explain the Fermi level in the N-type extrinsic semiconductor, the Fermi level in the P-type extrinsic semiconductor. I want to use that now. But then after I will explain that now, when the conductivity of the semiconductor is a minimum, how to find out the concentration of electrons and concentration of the holes and also conductivity. All these parameters I am going to explain. And also what is the Einstein relation, and also what is a graded semiconductor, what is the diffusion process, what formula will be used in the diffusion, everything we can discuss today. Understand that now. Now we can discuss about Fermi level in N-type extrinsic semiconductor. N-type extrinsic semiconductor. Extrinsic semiconductor. If the formula derivation is very simple, we can do that now. If it is a very complicated, then directly I will give the formula only now. Understand my point now. But here it is better to give the derivation part only now. Then students can understand easily now. Follow that now? But in the Fermi level in N-type extrinsic semiconductor, how we can find? I'll explain. Please do it then now. I'll give you the clarity. But we know very well concentration of electrons in a N-type extrinsic semiconductor is approximately equal to Nd. I said already the last class. N is approximately equal to Nd. Nd is said to be donor concentration. N is nothing but the concentration of electrons. Here the point what you have to understand, how N is approximately equal to Nd means, I said in the last class, you take intrinsic semiconductor and dope pentavalent atom. When the pentavalent atom is doped, I said already N equal to N0 plus Nd. In the last class I said, the last session I said exactly. N0 is nothing but the initial number of electrons existing in the semiconductor. Nd is nothing but the excess number of electrons attained by the semiconductor because of doping of pentavalent atom only now. Due to pentavalent atom, what concentration is going to increase means electrons concentration is going to increase. Even if the small amount of doping is made, the excess electrons are going to generate more in N-type extrinsic semiconductor. That can make the semiconductor conductivity to rise to a more only now. Understand that my point now. That means N is here, the N0 is very small here now. Nd is a very large. This is very large. This is very, very small practically. That is why we are putting N is approximately equal to Nd. I have taken here now. It's a very small, I neglected one now. That's why N is approximately equal to ND I have taken here now. You know very well, concentration of electrons equal to, I gave already, NC into e power minus of EC minus EF by KT. The last class I gave it. Sir, when will the mass capacitor going to happen? Mass capacitors mostly we need to check only now, because one by one we are doing, is it not now? May come or may not come only now, because 4 days session is now, 3 days over. Mass capacitor still it is a PN junction and also BJT, then after we need to go to mass only now, mass capacitor only now. We can see if there is a time we can explain now, understand now. Okay, N is approximately equal to ND. N equal to, I can write here now, here I can write N is nothing but NC into e power minus of EC minus EF by KT. By KT we can write now, whole divided by KT only now. EC minus EF by KT, whole divided by, understand now. You should try to understand, whole divided by KT, clearly you can understand. But this is approximately equal to ND I said. So I can write N is approximately equal to ND means NC into e power minus of EC minus minus plus EF divided by KT. That equal to ND I can write, approximately equal to ND. ND by NC I have taken here now, e power minus of EC minus EC plus EF equal to ND by NC, donor concentration by conduction band coefficient I can put now, conduction band coefficient. If you have taken log on both sides, I will get minus EC plus EF. If you brought this side, ln of ND by NC I can write here now. And what is EF? EF means Fermi level in n-type extrinsic semiconductor. If you want to write clearly means EFN also we can write, no problem, if you want, otherwise you can leave it as it is. Fermi level in n-type extrinsic semiconductor, in n-type extrinsic semiconductor. And finally I wish to find what is EFN. EFN is nothing but EC plus ln of ND by NC we can write now. But we cannot stop by this extent, because why it should not be stopped means you can understand clearly. But Fermi level energy in the n-type extrinsic semiconductor is going to lie just above the EC, or it is going to be lying on the above EC or overlapping on EC, otherwise below EC is mostly possible. Practically the doping is made very, very small. When the doping is made very small, Fermi level in the n-type extrinsic semiconductor always lie below the EC level only. If the doping is made moderate, you think it's so. At the time Fermi level in n-type extrinsic semiconductor is going to overlap on what EC only now. If doping is made more, you think it's so. At the time Fermi level in n-type extrinsic semiconductor is going to cross the conduction band energy only now. EC level it can cross only now. But generally what now in practical application EFN lies just below the what now EC level only now. If you want to get the below what now EC level means EC minus something is required now. But this value, total value, is a positive value or negative value is unknown so far now. But just by watching the formula, idea is going to create EFN is nothing but EC plus something is there now. EC plus something means it may be what now above the EC we can think only now. At the time if you made EC minus something, you will get the what now idea. Yes, EFN lies below the EC level only now. That is why what I wish to do, EFN I want to write in this way, EC minus, whenever you are writing the minus, this we can reciprocate, ln of I can write ND by NC I can write now, ND by NC. By using this formula, you can determine. By using this the formula, Fermi level in n-type extrinsic semiconductor, you can calculate. By kT is there now, that kT is removed only here now, sorry. By kT is existing from the beginning. By kT is existing here already. It is existing one kT. Yes, now perfect. EFN equal to EC minus kT into ln of ND by NC. Why this kT means already from the beginning kT is there now. Understand now. This is the formula we can apply only now. Now, how that energy band diagram will be plotted here now? If you want to draw the energy band diagram for the n-type extrinsic semiconductor, I can put like this. This is the, this point is said to be EC here. This is to be taken as a EV here. This is EV. But EFN will lie very close to this only now. This is EFN. This is EFN is possible. This is the Fermi level energy. This is the energy band diagram. Energy band diagram of n-type extrinsic semiconductor. Extrinsic semiconductor I can put now. That way we can draw here now. But in this case, sometimes in the problems you will go asked to find EC minus EFN equal to how much. This energy level you will ask to find sometimes. EC minus EFN how much. In that case, you know very well EFN we got already. We got EFN. What do we got? EFN EC minus KT into ln of, what is written? ln of ND by NC I gave it. ND by NC it is written here now. But this energy is required. So in the problems you will ask in the gate EC minus EFN equal to how much? That energy required means we can write now EC minus EFN if you want to find. In the problems you can use now KT into ln of ND by NC we can write it now. Yes, this formula you must use. The formula is to be used to find out this energy level. This energy level. I hope you followed this now, understand now. But this way we can find out the what now? EC minus EFN now. For the now we can see how to find out the Fermi level in the p-type extrinsic semiconductor, how that energy band diagram will be there now. I will explain now, understand now. The next one is Fermi level energy. Fermi level energy in p-type extrinsic semiconductor. Extrinsic semiconductor. Extrinsic semiconductor. How this will be taken here now. The Fermi level in p-type extrinsic semiconductor means we know very well. The concentration of holes in p-type extrinsic semiconductor is approximately equal to what I said, Na. In n-type extrinsic semiconductor, we have taken N is approximately equal to Nd. Nd is nothing but the donor concentration I said. In p-type extrinsic semiconductor, P is approximately equal to Na. Na is nothing but the acceptance concentration. How it is approximately equal, sir? We know very well. You have taken intrinsic semiconductor. It is doped with trivalent atom like boron. The trivalent atom is doped a small quantity, not large quantity. Large quantity should not be added at any cost. If you are adding the more number of what you can say now, impurity atoms to think it so, at the time what is going to happen here now, whenever the atoms are increasing more and more, the collision rate is going to be increased in the semiconducting materials only now. The electrons can be moved and they are going to make the they are going to trap in the holes very fast only, you can say. That means collision rate will be increasing more and more, When the collision rate is increasing more and more, conductivity will be decreasing, That's why when the doping is made more in the semiconductor, at the time conductivity of the semiconductor will be decreasing drastically, That's why nobody is going to add more only now. Understand my brother? That is why they are going to use minimum quantity only. That point very important now. But I said already in the p-type extrinsic semiconductor, trivalent atom you do approval now. Majority carriers are nothing but the holes. What concentration of holes existing in the p-type extrinsic semiconductor means you know very well. P0 plus acceptors concentration. Na is nothing but the acceptors concentrations, holes formed because of the doping only now. P0 is nothing but the initial number of the holes only, we can say. But practically we know very well Na is far more greater only now. Na is far more greater than P0 value. This Na will be very, very large possible. At the time P is approximately equal to Na, we can write it now. P is approximately equal to Na. That is why this point is applied here now. P is approximately equal to Na only now. But in this case, the total P is nothing but we know very well the value of P. Concentration of the holes in the last class I explained. The P equal to, we can write valence band coefficient NV into e power minus of, what I gave it, what is given already, EFP minus what is required, EV divided by KT. We need to use only now. But if it is a NC into e power minus of EC minus EFN by KT I gave it. For P type, minus of EFP minus EV by KT, because EF is a larger value, EV will be lower value only possible. But in this case, I want to take e power minus EFP minus plus EV divided by KT, that equal to how much? The P is approximately equal to what I said, Na only now. This is equal to Na. P is nothing but Na we can write. Na by, so Na by NV is possible here. Na by NV is possible. But taken log on both sides. If taken log on both sides, I will get minus of EFP plus EV divide by KT you will get here now. But even it is taken this side ln of Na by NV we are going to use. So directly you can give formula. Suppose the student has forgotten the formula, at least they can do this work and they can apply the formula. What about minus EFP plus EV, that equal to KT into ln of Na by NV. But I want EFP, Fermi level in p-type extrinsic semiconductor. EFP is required. EFP is nothing but EV minus KT ln of Na by NV. Now this formula cannot be taken directly here now. Why it should not be taken like this sir now? Because here suppose ln of, but EV minus something I got here now. But this is, the value is a positive value or negative value is unknown. EV minus something. That something may be positive, everybody will think generally. EV minus something, if it is taken, EFP may be existing below EV level only now. EV minus something means less than EV only possible, EFP. EFP will not lie below the EV value. EFP always lies just above the what now? Yes. Sir, in tomorrow class, teach the special diodes class in one shot. Okay, shortly we can arrange, no problem now. It is not a big problem only now. Special diodes or MOS capacitor, whatever it may be, it's possible to do only now. We can arrange the what special hours for that. We can do that, no problem. We can discuss with the management, no problem. Understand? But EFP equal to EV minus KT into ln of NA by NV only now. And I can say this now, EFP must be above EV required. Above EV means we can write like this now, EFP equal to EV plus KT into ln of NV by NA, I can write directly, NV by NA. So, by using this formula, you can get the EFP. You must remember this formula. You must remember this formula only. Gate point of view, this formula is required. Start point now. So, Fermi level in P type also we got it now. Now, I will draw the energy band diagram for this, you will understand clear now. How that energy band diagram? The energy band diagram will be plotted like this. This is EC. This point is taken EC. And this is to be taken as a EV here. EV comes here only now. But I am getting the EFP just above the EV, EV plus something only now. It comes like this now. It comes very close to the EV only now. It comes here like this now. EFP again right now. So, this is the EFP value we are getting now. Sometimes in the problem you will be asked to find out EFP minus EV. This energy level you will ask in the problems in the gate. This energy level how much? If you want to find that energy level, what you have to do? EFP minus EV required. EFP we got already. We got EFP already. What is EFP? EV plus KT ln of KT into ln of NV by NA. NV by NA. Yes, this we know very well. But I want energy level between these two, EFP minus EV. I can write EFP minus EV. If you want to find, you must use this formula, KT into ln of NV by NA. Yes, you must remember this formula only now. The difference of the energy, this difference of this energy, if you want to find, you must mug up that formula only now. Follow this? That way we can find out. But Fermi level in intrinsic semiconductor I explained, Fermi level in the P-type extrinsic semiconductor I explained, Fermi level in the N-type also I explained. And few more important points I want to give here now. What those points? You please listen. But when the conductivity of the semiconductor is a minimum, how to find out the concentration of electrons and concentration of the holes? That also I want to give here now. I want to give concentration of, sometimes asking in the gate, concentration of electrons and holes, concentration of electrons and holes at minimum conductivity. At minimum conductivity. Sometimes asking questions based upon this formula also. Electrons concentration and the holes concentration, to find what those formulas are required, and also minimum conductivity also required here now. We can find now. We know very well the total conductivity in a semiconductor is nothing but conductivity due to electrons plus conductivity due to holes only now. Sigma equal to sigma n plus sigma p you can write now. Addition of these two will be said as a total conductivity only now. But I want at minimum conductivity concentration of electrons and concentration of holes required here now. Conductivity equal to, you know very well, conductivity due to electrons you know very well. The last class I did, n into q into mu n. Charge density into mobility is nothing but the conductivity. Charge density is nothing but n into q. mu n is the mobility, that is the conductivity due to electrons. Conductivity due to holes is nothing but in the place of n you will get the P, concentration of holes into Q into mu P, you will use generally. In the problem it is not specified the given type of the given material is the intrinsic semiconductor, it is just a semiconductor only given now. In this semiconductor I can't take n equal to P equal to Ni, I can't use this because it is not an intrinsic semiconductor, understand my point now. Suppose I want to find the concentration of electrons to think it so, you convert P in terms of n, you convert P in terms of n by means of using the mass action law only now. Without mass action law we can't do only now. We know very well mass action law is nothing but n into P equal to Ni square, the last class I explained. But I want to get the concentration of electrons at first. P you convert in terms of what now? N only now. So P equal to we can write Ni square by n. This P I can substitute in the above equation. Sigma equal to I can write n into Q into mu n. P is nothing but Ni square by n into Q into mu P I can write. I can write such a way only now. But in this case, in terms of n I got, we don't have any concentration of the holes in this particular equation now. At minimum conductivity, I want minimum conductivity means to differentiate on both sides with respect to n. According to maximum and minimum, you know very well, derivative of that function is equal to 0, it is to be taken now, according to maximum minimum. So the maximum minimum condition I want to apply. At minimum condition, first to differentiate with respect to n, d sigma by dn I want to take. If you differentiate with respect to n, Q into mu n I will get, Q into mu n. Here 1 by n differentiation minus 1 by n square, 1 by n square into Ni square into Q into mu P I can write here now, Q into mu P. We know very well this value d sigma by dn is to be taken as a 0 only now. According to maximum minimum, d sigma by dn, d sigma by dn can be taken as a 0 only, must be equal to 0 according to maximum minimum only now. Put directly you can write now, put this. If you are putting this as a 0 value, I will get Q into mu n minus 1 by n square into Ni square into Q into mu P I can write here now. Thereby cancel Q term directly. I can cancel Q terms. My aim is to find the n. So I can write here now 1 by n square, but the mu n equal to we know very well, Ni square mu P divided by n square. The finally what is n you calculate. N is nothing but Ni into under root of mu P by mu n. Yes, this formula you must mug up. You must mug up this formula only now. Whenever in the problem you are given mu P value, mu n value and a Ni value, you are asked to find out the concentration of electrons at minimum conductivity. Directly you can use this formula. This is just for understanding I explained only now, but finally you need to mug up this formula only now. N equal to Ni into root of mu P by mu n. In the same way, if you want to find the concentration of the holes, what to do? Total conductivity, how to get, how to find out the total current density. These are all we can see now. Suppose you want to find the next one. So the concentration of holes I want to find. To find concentration of holes. To find concentration of holes at minimum conductivity I want to find. At minimum conductivity. If you want to find the concentration of the holes, the same concept only now. The same concept means what is the total conductivity, you take it. Conductivity due to electrons plus conductivity due to holes is nothing but the total conductivity. But we can write sigma n, we know very well. Just now I explained n into q into mu n, you can write directly. What about sigma p star? Sigma p can be taken as a p into q into mu p, you can write directly. But in this particular equation, we need to eliminate the what n term only now. Eliminate means you should not remove directly now. The n you convert in terms of the p only now. What way? By applying the mass action law. If I apply the mass action law, I will get n equal to, I can write ni square p, n equal to ni square by p, you know very well, according to mass action law. This I want to substitute here now. Total conductivity is nothing but ni square by p into q into mu n I can write, plus p into q into mu p I can write. But here at minimum conductivity I want this value. At minimum conductivity means you must apply differentiation on both sides. Differentiate on both sides with respect to p. d sigma by dp. d sigma by dp means 1 by p square here. 1 by p differentiation, 1 by p square into ni square into q into mu n I will get. Here the derivative of p is nothing but 1. I will get q into mu p plus q into mu p I can get. But a derivative equal to, you know very well, according to maximum and minimum, d sigma by dp equal to, you can put directly 0, you know, as per maximum and minimum. If it is equated to 0, I can get minus 1 by p square into ni square into q into mu p mu n plus q into mu p we are getting. That value we are getting. Thereby cancel this q term. I can write mu p is nothing but ni square into mu n by p square I can get now. My aim is to find out the p value. If you want to find the p value, you must use this formula, ni into under root of mu n by mu p. Yes, this is the formula you must remember in the GATE exam to do the problems. The formula is important. So, what is the way to find out the concentration of electrons or the holes? I explained through derivation here now. But when the concentration of the electrons and holes, if you know, you can calculate the required value of the conductivity also. What is the minimum conductivity possible in the semiconductor? Suppose you are asked, you can find by using these p and n values now. I will give you how to find out the conductivity also now. Suppose you want to find out the conductivity, minimum conductivity I want to find. If you wish to find out the minimum conductivity, same formula, n into q into mu n plus p into q into mu p. One more formula you can create here now. But you know very well what is n. I gave already concentration of electrons, you got already ni into under root of mu p by mu n I gave it. Into what? This is a mu n we are getting here now. The concentration of the holes I gave already, what I gave it, concentration of the holes, ni into root of mu n by mu p we got now. If I substitute it, what happens to was? The p is nothing but ni into under root of mu n by mu p. Into mu p I can write here now. Then you can simplify. Final formula what it comes to was sigma minimum is nothing but mu n root of ni into root of mu p here. Root times you can cancel this now. Root of mu n I can get. Plus ni is here now. Root of mu n is there here. Root times you can cancel here now. Root of mu p you can get here now. And finally I can write formula like this. Sigma minimum is nothing but ni is taken common here now. Intrinsic concentration is ni is there now. So, okay, this is a root of ni I will put as you know, mu n mu p plus ni into root of mu n mu p you are going to get. And finally, sigma minimum equal to how much? 2 into ni into root of mu n mu p is possible. Mu n mu p is possible. Yes, we should apply this formula now. The addition of these two is made. It's total conductivity. If you want to find this formula, you must use Ni into root of this value we are getting now. Here this we are getting now. Understand now? That formula you need to mark up on the vacancy now. I hope you followed. Any doubts, anybody? Any students having any doubt regarding this? Suppose you are asked to find out the what now? Resistivity, suppose now. Resistivity at the minimum condition. What way we can use? If you are wishing to find out the what now? Rho at the minimum conductivity. Rho is nothing but the reciprocal of the what now? Conductivity only now. Rho is the reciprocal of conductivity, you know very well. And that we can get directly only now. What we can do now? 1 by 2 Ni root of mu n mu p we can put here now. Yes, that formula you can use only now. Like that, calculation will be done now. Understand now? Any value you can determine by using these conditions only now. Conductivity, minimum resistivity, I explained only now. Understand my point now? Anybody having any doubts? Anybody? Anybody? Just one small question I will give. How many students can do this question? I will see now. Can you find without my help? Find, I am asking, find rho intrinsic divided by rho intrinsic semiconductor divided by rho minimum equal to how much? That ratio I am asking to find. Anybody can try without my help. I will wait for some time. Please try to tackle this question without my help. Already you have done rho minimum, what are this rho value for the intrinsic semiconductor. Rho minimum also we got it now. That ratio you can find easily now. Please try to find that value easily. I will wait for some time. You please complete. Start doing this question. Start doing this question. Anybody? But I want to give you some time. Just write and please give the result. Anybody? Anybody can do this question? You know already I have done what is a rho for the intrinsic semiconductor I gave it, rho minimum also I did it. So you calculate, you try, if you are getting answer very good now, just to practice this now, understand now. Okay, next question I will give. Next I want to explain, next one I want to explain here is graded semiconductor. Graded semiconductor. Graded semiconductor. But anybody can define what is graded semiconductor? Can you message? Can you text? I want to know how many students can give answer. Anybody can define graded semiconductor? Anybody? Anybody having any idea? No idea. Anybody having any idea? No idea. Graded semiconductor is nothing but, you take a semiconductor for example, you take one semiconducting material, that is an intrinsic semiconductor I have taken here now. The doping is made, but the doping is not made identical in between any 2 points. In between any 2 points of the semiconductor, doping is not made properly. It means improper way doping is made. Improper way means at one particular point we are going to find the more concentration or more doping. and at other point the concentration of the doping is less only possible. That means when the difference of the concentration of the doping is made in the semiconducting material, at the time it is said to be graded semiconductor. It means it is not uniformly doped. There is nothing but what material? It is a graded semiconductor. If impurity is not doped, if impurity is not doped uniformly, in semiconductor, then it is said to be graded semiconductor. That semiconductor is called as a graded semiconductor only now. That is said to be graded semiconductors. That point very important. Sir, why you are explaining about this graded semiconductor? Because when the student wants to learn the mechanism of the diffusion, you think it's so, they must understand well about the graded semiconductor. Without knowing the definition of the graded semiconductor, I can't explain the diffusion mechanism in the material. That's why initially I gave the explanation for the graded semiconductor. By using this graded semiconductor, I would like to give the information regarding the diffusion. Now I will explain the diffusion. And what formula we have to use in the diffusion, I will explain. Diffusion. How to define diffusion? For example, I selected here graded semiconductor. This is the graded semiconductor. This is to be taken as a graded semiconductor. Just now I explained in the graded semiconductor you cannot find the concentration of the charges uniformly. Here we can find one side higher concentration of the higher concentration of the charges, other side you can find the lower concentration only. Difference of the concentration of the charge carriers are going to exist in this type of semiconducting material only now. Here I got the concentration in this way. One side I got the more concentration, maybe holes or electrons. Suppose it is a p-type extrinsic semiconductor, hole concentration must be more. Higher concentration this side. This side I got the lower concentration. The difference of the concentration, UV height. Okay, if the difference of the concentration it is existing, what is going to happen? At the time, the mechanism of the diffusion is possible. Diffusion means the movement of charge carriers from higher concentration to lower concentration. Higher concentration to lower concentration. You cannot find, if the semiconductor is not uniformly doped, you think it's so. What a non-uniform manner it is not doped, you think it's so. I say high, okay, high. But the semiconductor you got, suppose it is a uniformly doped, we can assume for example. If it is uniformly doped, you cannot find the mechanism of the diffusion. We cannot find. Why? If there is no difference of the concentration, we cannot find any mechanism of the diffusion. The mechanism of the diffusion must exist in the semiconducting material, you think it's so. At the time we must say it must exist difference of the concentration only. Then only the mechanism of the diffusion is going to take place. The definition I can give like this now for the diffusion now. Movement of charge carriers. Movement of charge carriers. Movement of charge carriers from higher concentration to lower concentration. Lower concentration is called diffusion, we can say. That only we can call it as a diffusion. one side we got the higher concentration of the charges, other side lower concentration at the time that the diffusion is going to take place, higher to lower. How long the diffusion is going to take place? In the semiconductor, how long diffusion is taken place means one side, but both sides concentrations are equal. At the time, no more difference of concentration we can find. At the time, what is going to happen now? Diffusion is directly ceased. It will be stopped only, we can say now. Anyhow, definition is this. But what formula here required here now? In the problems it is required, coefficient of diffusion is required. In the gate questions, if you want to do the gate questions, you must remember this formula. Coefficient of diffusion. This is very important, gate point of view. How to find out the coefficient of diffusion? I can say one point in the electrical engineering, one formula is there now. Current density is directly proportional to charge into gradient. There is a formula in the electrical engineering. I say current density here, the current density is taken place due to holes. If you got the electrons, I can write current density due to electrons only now. As I selected in the material majority carriers of the holes this side, I have taken current density due to holes I want to take here now, due to holes. Current density due to holes is directly proportional to charge into gradient we can write. Charge into gradient or slope, any word you can use. Charge into gradients. But in the y-axis side, we are finding the concentration P. It is moving some distance this side, x. Slope is nothing but dP by dx. We can write directly. I can write current density due to holes. I would like to define by the symbol Jp. Is directly proportional. The charge is to be taken as a Q. And gradient is to be taken as a dP by dx. I can put here now, dP by dx. I can write now. Finally, I want Jp, current density due to holes I want to find. The proportionality constant is given a name minus d suffix p into q into dP by dx. It is to be taken. This is the formula for the what now? Coefficient of diffusion means what now? dP only called as a coefficient of diffusion only, where dP equal to, I can write, where dP equal to coefficient of diffusion, I can say. Coefficient of diffusion I can write. So students will get one more doubt here now. Sir, you have taken here now Jp equal to minus dP into q into dP by dx. But why it is taken minus, sir, now? Why you are not putting the minus plus? Why they are taken minus means one side higher concentration you got, one side higher concentration. Because the mechanism of the diffusion, charge carriers are going to reduce here now. That means a reduction of the charge carriers are taken place where you find before higher concentration. Reduction of the charge carriers indicates negative sign only now. Minus sign indicates reduction of the charge carriers, where at the initial point of this only now. Reduction indicates minus only, you can say now. And finally, dP value required means what formula you can use? So we can write dP equal to minus of q into dP by dx divided by what? Jp. This is the formula you must remember in the problems. This is the one of the formula required. Follow this now. dP equal to Jp by only now. Sorry, made mistake. Reverse I have taken. The dP I want to get here now. Minus of dP means Jp by what you can write now? Q into dP by dx. Q into dP by dx. Yes, this formula you can use to find out the coefficient of diffusion only now. That formula required. but I hope you followed now. But can you say, suppose the Dn value you want to find, coefficient of, because suppose I have taken graded semiconductor is nothing but the N type only now. Electrons concentration is existing more one side. The other side we are finding the concentration of the electrons less. At the time, can you say how to find out the Dn value? Dn, if you want to find, means you must use Jn by Q into Dn by dx. Q into Dn by dx. For electrons, it is to be taken with a positive sign only. For the holes, you must take minus value, understand. Why here how it became plus R? The charge of this electron is in the minus of something only now. Minus of negative value only. Electrons means minus of 1.6 into 10 power minus 19. Minus and this minus becomes a plus only now. Minus minus, it becomes a plus because the Q value minus 1.6 into 10 power minus 9. But here it won't become a plus with the Q value is a positive only for the holes only there. So that minus will be existing same. So these two formulas are very important only, we can say. Understand my point now. In the next section, I will explain what is Einstein relation, what is the thermal equivalent of the voltage, what is the electric field intensity versus drift velocity relationship. Those are all will be explained tomorrow only now. Understand my point now. Okay, then so far you followed, I hope it now. Thank you.